Find the slope of the line in the graph. And just as a bit of a review, slope is just telling us how steep a line is. And the best way to view it, slope is equal to change in y over change in x, over change in x. And for a constant, this will for a line, this will always be constant. And sometimes you might see it written like this. You might see this triangle. That's a capital delta. That means change in y over change in x. That's just a fancy way of saying change in y over change in x. So let's see what this change in y is for any change in x. So let's start at some point that seems pretty reasonable to read from this table right here, from this graph. So let's see, we're starting here. Let me do it in a more vibrant color. So let's say we start at that point right there. And we want to go to another point that's pretty straightforward to read. So we can move to that point right there. We can literally pick any 2 points on this line. I'm just picking ones that are at nice integer coordinates, so it's easy to read. So what is the change in y and what is the change in x? So first, let's look at the change in x. So if we go from there to there, what is the change in x? My change in x is equal to what? Well, I could just count it out. I went 1 step, 2 steps, 3 steps. My change in x is 3. And you can even see it from the x values. If I go from -3 to 0, I went up by 3. So my change in x is 3. So let me write this. Change in x, delta x is equal to 3. And what's my change in y? Well, my change in y, I'm going from -3 up to -1. Or you could just say, 1, 2. So my change in y is equal to +2. So let me write that down. Change in y is equal to 2. So what is my change in y for a change in x? Well, when my change in x was 3, my change in y is 2. So this is my slope. And one thing I want to do, I want to show you that I could have really picked any 2 points here. Let's say I didn't pick, let me clear this out. Let's say I didn't pick those 2 points. Let me pick some other points, and I'll even go in a different direction. And I want to show you that you're going to get the same answer. Let's say I view this as my starting point, and I want to go all the way over there. So what is my, well, think about the change in y first. So the change in y, I am going down by how many? How many units? 1, 2, 3, 4 units. So my change in y in this example is -4. I went from 1 to -3. That's -4. That's my change in y. Change in y is equal to -4. Now what is my change in x? Well, I'm going from this point, or from this x value, all the way, let me do that in a different color, all the way back like this. So I'm going to the left, so it's going to be a negative change in x. And I went 1, 2, 3, 4, 5, 6 units back. So my change in x is equal to -6. Change in x is equal to -6. And you could even see I started at an x is equal to 3, and I went all the way to x is equal to a -3. That's a change of -6. I went 6 to the left, or a change of -6. So what is my change in y over change in x? My change in y over change in x is equal to -4 over -6. The negatives cancel out, and what's 4 over 6? Well, that's just 2 over 3. So it's the same value, you just have to be consistent. If this is my start point, I went down 4, and then I went back 6. -4 over -6. If I viewed this as my starting point, I could say that I went up 4. So it would be a change in y would be 4. And then my change in x would be 6. And either way, once again, change in y over change in x is going to be 4 over 6, 2/3. So no matter which point you choose, as long as you kind of think about it in a consistent way, you're going to get the same value for slope.